Welcome to my third discussion on the time value of money to accompany Spiceland 7th edition. In this short discussion, I would like to talk about the present value of a single amount. Although we're talking about the present value of a single amount, which is in your book on page 324, it's natural to review the single value amount. Remember on page 4 of our notes, we made a future value interest factor table for $1 for 10% through 4 years by taking $1 and growing it for 4 periods, and it started at $1 and it ended at $1.46. If you take this and you graph it for a 4-year period, you will see that it grows to be, you got to be loose in your interpretation. It should be right here. I couldn't curve this line. It would really go something like this. But my point is the $1 would grow on a 10% growth curve going out over 4 years, and that would be a 10% growth curve. So you could go out on this chart using table 1. Table 2 would bring you back. If you know how much something is worth at the end of 4 years, how much is it worth now? So you know that it's worth $1.46 at the end of 4 years. Can you get back to the $1 amount? You can do this using table 2. It's a reciprocal relationship. Table 2 is the reciprocal of table 1, which means you could take the numbers on table 1 and say 1 divided by whatever number on table 1 would equal the number on table 2. Consider the formulas. It is exactly what I said. Take 1 and divide it by the formula on table 1. So let's do that. To create table 2, you can use the reciprocal of table 1. I would like you to complete the last 2 rows, but I'll show you how to do the second row. If you take 1.10, 1 divided by 1.10, you get 0.90909. If you take 1 divided by 1.2100, you get 0.82644. Now you put this on hold and continue this table for me using the formula I showed you right here. When you finish the table, you can see on the 4th year you end up at 0.68301. Now follow that to a screenshot of table 2 where you come down n equals 4 and I equals 10 and you get 0.68301. You know, what a rotten job. Some poor fool had to take $1 and grow it by 10% and make table 1, and then take the numbers on table 1 and divide them by that number to make table 2. Never complain about your job again. So let's consider our formulas. The formula for the future value is take the present value and times it by an interest factor, a future value interest factor, table 1 with an n and an I. The formula for table 2 is take the present value and take the future value and times that by an interest factor from table 2 to get the present value. So you can start with table 1 and convert it to table 2. How much, answer this question for me, how much would $1.46 be worth today if you had to wait 4 years to receive it? Notice how I made my time diagram. I have 4 years. I'm wondering what something's worth today, so I know it's a present value table, and I know the future value amount. I can take the future value amount, 1.4641, and times it by that interest factor, 6830, that we calculated above, and I'll get back to 1. Table 1 and Table 2 always lead to the same fund accumulation schedule. They start with the present value and they end with the future value. If you know the future value and you're trying to get back to the present value, you use Table 2. If you know the present value and you're trying to get to the future value, you use Table 1. Well, Table 2 is also built on how much $1 would be, so you can use it as an interest factor. If it works for $1, it will work for any amount of dollars. So how much is an investment that is worth $7,320 today? Quit fooling around, huh? How much is an investment that's worth $7,320 at the end of 4 years be worth today? Notice why I put my question mark. If I know I can earn 10% over that 4-year period. Well, I would take my future value of 7,320 and then I would need to times that by a present value interest factor from table 4 at 10%. Backing up a page, you can see the interest factor for 10% in 4 years is 0.68301 times 7,320, the amount we know it will grow to be, by that interest factor from table 2, 0.68301, and it will come up to be $5,000. Now I know there's a little bit of a rounding error, about 40 cents there, but remember we've agreed not to let errors bother us as we study intermediate accounting. Remember that table 1 and 2 always share the same fund accumulation schedule. You know where you started, and when you apply 10% to it and grow it for 4 years, if you end at 73.20, you've proved that $5,000 is the present value of 7,320. If taken back 4 years at 10%, that's called discounting it back. And you also know that $5,000 will grow to be $7,320 if invested at 10% for a 4-year period. The same accumulation schedule works for both because they have a reciprocal relationship. It's your turn now. If you need $10,000 in an account to buy your car a child in 4 years and you know you can earn 12%, how much do you need to set aside today? I need 10,000. I'm looking for the amount today, so there's my question mark. You know that you need to work out this number by taking $10,000, the future value, and timesing it by an interest factor. So look that up on the table for n equals 4 and I equals 12. The first thing you find is the interest factor is 0.6355. 10,000 times 0.6355 equals $6,355. So you know your fund accumulation table starts with the present value and you know it ends with the future value. Your turn. Fill out the fund accumulation schedule for me. How'd you do? 6,355 times 12%, 763. Add that together, 7118. That's what the balance would be at the end of year 1. Leave it in for a year, 7118. Will earn 854 if invested at 12% and grow to be 7972. The third year begins at 7972, stays there all year, grows by 12% or 957, becomes 8929. When invested for another year at 12%, it will grow by 1071 and it will end up at 10,000. Notice it started with our present value and ended with our future value. What works for $1 will work for any number of dollars. It's now time for you to read page 323 through page 330, excuse me. And I want you to remember in the end that table 1 and table 2 were charts used building $1. They're interest factors then, so they can be used for any amount of dollars to solve problems. They're reciprocals of one another. But they do require a constant rate of interest and an equal period of time if you're going to use it, meaning you're always compounding annually or always semi-annually, or always quarterly, and the interest rate isn't changes. If one of these three things break down, you can still solve problems using the tables. You just can't use you need to accommodate that in your approach. Let's just say it like that for now. Hey, thanks for joining me. We'll talk again soon.